Mean value theorem and its very close related theorem, Rolle's theorem. The mean value theorem, if f is continuous on the interval, closed interval a to b, and differentiable on the open interval a to b, there exists a number c in the open interval a to b such that f prime of c equals f of b minus f of a over b minus a. And verbally, that's where the instantaneous rate of change equals the average rate of change. And graphically, it says this. It says where the tangent line is parallel to the secant line. So let's go ahead and just graphically demonstrate what's happening here. We have some function. We call this function f, like this. And we have two input values. We'll say we have a over here, and we have b over here. And so we have f of a right here and f of b here. And so what this is saying is that this f of b minus f of a over b minus a, we have the secant line, trying to draw a more or less straight secant line. That's pretty good. The slope f prime of c, right here, this secant line has a certain slope. Well, there is going to be, if this, given this function is continuous and differentiable over this interval from a to b, there's going to be a secant line. I'm going to try a tangent line that is parallel to the secant line. So this black tangent line is parallel to the secant line in at least one place. And that place will be called the value c. And we can go right up here. And here's f of c. And at c, the tangent line is equal to the slope of the tangent line is equal to the slope of the secant line. Okay, let's go on. Here we have a problem. Let f be the function given by f of x equals x cubed minus 7x plus 6. Find the number c that satisfies the conclusion of the mean value theorem for f on the closed interval 1 to 3. Well, what we're going to find, first of all, is what we call our a rock, which is f of b minus f of a over b minus a. And here we are given 1 is going to be a, and 3 will be b. And so that is going to equal, okay, we're going to plug in 3. F of b is going to be f of 3. That's going to equal 3 cubed minus 7 times 3 plus 6, which is going to be equal to 3 cubed is 27, and minus 7 times 3 minus 21 plus 6. So 27 minus 21 is going to be 6 plus 6, so that is going to be equal to 12. So here we put in the f of b position 12 minus f of a. Here we're going to put down f of a, which is f of 1, equals 1 cubed minus 7 times 1 plus 6, and that's going to equal 1 minus 7, which is going to be negative 6 plus 6, which equals 0. So we have 12 minus 0 over b minus a, and b is 3, and a is 1. So we have 12 over 2, which equals 6. So this is going to be our slope. This is our a rock. And so what we're going to do is find that value c that satisfies this mean value theorem. So we will find f prime of x. and that is going to be 3 times x squared minus 7. And there's a value, so we're going to say that the average rate of change is 6. So we replace f prime of x with 6. 6 equals 3x squared minus 7. And so we're going to go ahead and solve for x by adding 7 to both sides. And so we have 3x squared equals 13, and then we divide by 3. So we have x squared equals 13 thirds, and so square root both sides, we have x equals plus or minus square root of 13 thirds. And let's see, 13 thirds, that's going to be a little bit bigger than 4. So it's going to be a little bit bigger than 2. So we're going to be able to eliminate the negative sign one. So our number c, where the slope is the same, is going to be, c is going to be equal to the square root of the fraction 13 over 3, a little bit bigger than 2. And this is where the slope is going to be 6, which is the AROC. So it's where IROC equals AROC. And that will be at the point where x equals the square root of 13 over 3. Next, problem 2, and we see this is a calculator problem. Let f be the function defined by f of x equals x plus the natural logarithm of x. What is the value for c, for which the instantaneous rate of change of f at x equals c is the same as the average rate of change of f over the closed interval 1 to 4. So we're going about the same process that we did on our last problem, except we're going to be able to take advantage of a calculator. So the process is going to be the average rate of change is going to be equal to f of b minus f of a over b minus a. And so f of b is going to be plugging in for this equation. We have, let's say, a is 1, b is 4. So f of b is going to be 4 plus the natural logarithm of 4. Natural logarithm is really what power do we need to raise e2 to equal 4. And for that, we're going to go to our calculator, and we're going to say, we're going to get ln4. So control logarithm of 4. Okay, we get 1.38629. And we're going to add 4 to that because that's what we need to find. So we're going to get 5.38629. Let's go over here. 5.38629. We might be tempted to round off, but what we're trying to do is get as many significant figures as possible before our final answer, because you need to get at least 3 significant figures right to get this right. So f of a is equal to x, which is 1, plus the natural logarithm of 0. So natural logarithm of 1. And natural logarithm of 1 is simply what power do we need to raise e to equal 1? Well, that's going to be 0. So we're going to have 1. So minus 1 here over b minus a, which is going to be 4 minus 1. So it's going to be this value, 5.38629 minus 1 over 3, which equals, and we're going to go to the calculator for that again. Let's see, we're going to say it's going to be 4 point, let's see, 4.38629, and that'll be divided by 3. Now we get 1.4621. So that's going to be our average rate of change. So 1.4621. That's going to be approximately, really, but this will be A rock. Now we're going to have to go ahead and take f prime of x. F prime of x equals the derivative of x, which is 1, plus the derivative of ln x, which is going to be the derivative of x over x. So that's going to be our derivative, and now we're going to take this a rock and change places with f prime of x. So we have 1.4621 equals 1 plus 1 over x. And so what we can do to solve for x by graphing, we can set one side of the equation equal to 0. So we have 0 equals 1 plus 1 over x minus 1.4621. And for that, we're going to go to our graphing calculator again. And this time we're going to pull up a graph page. And we're going to say 1 plus 1 over x minus 1.4621. We graph that equation, and between x equals 1 and x equals 4, we're going to be right a little over 2, it looks like. And to find exactly what it is, we go to menu, we go to analyze graph, and we go to pick the top 0, and we set a left boundary here, and we set a right boundary here, and we get 2.16, and we have the hand over it, and we press the plus key. I think this is it. Okay, we get all these significant figures. 2.16403. So significant figures, we get 2.160. No, 2.164. 2.164. Okay, so this would be our IROC, instantaneous rate of change. Well, where it occurs where x equals 2.164, and that's going to be what our value of c is. So at c equals 2.164, that's where we're going to have the same, c is the same as the average rate of change. So instantaneous rate of change at x equals 2.164 is the same as the average rate of change over this closed interval from 1 to 4. Okay, Next, Rolle's theorem. Well, Rolle's theorem is really just a subset of the mean value theorem. And the only distinction between Rolle's theorem and the mean value theorem is that f of A and f of B have to be equal. Okay, and then if that's the case, there's going to be at least one number C in the open interval A to B where f prime of C equals 0. And again, the function has to be continuous and differentiable over the entire open interval from A to B. And so graphically, we're looking at we'll make a similar drawing to what we did last time, except you have to have A right here. Say this is A, and B is right here. Well, f of A has to equal f of B. All right? And if f of A equals f of B, we have a slope between of our secant line is going to be what? This horizontal line, the slope of that horizontal line is 0. And therefore, there's going to have to be at least one number between A and B, so the tangent line is horizontal. And here the tangent line is horizontal right at the top, not drawn exactly at the top, but right at the top. And so that value, input value, is going to be C. So really we have, if we have a Venn diagram, we have the mean value theorem will apply to all these, and within the Venn diagram we have Rolle's theorem, RT. So all cases of Rolle's theorem are actually part of the universe of the mean value theorem, but of course not all mean value theorem situations are the Rolle's theorem. So let's go on to problem 1. Determine whether Rolle's theorem can be applied. If so, find C. If not, tell why. Well, really to do this, we're going to need to find, again, we have A and B. Okay, we're going to say f of A is going to be equal to negative 2 to the 4th power minus 2 times negative 2 squared, which is going to be negative 2 to the 4th power. Well, that's going to be 16, I believe. 2 to 4, 16 minus, let's see, 2 times negative 2 squared. That would be minus 8, which equals 8. Now for f of B, we're going to have there'll be 2 to the 4th power minus 2 times 2 squared, and that's going to likewise equal 16 minus 8, which equals 8. And so here we have f of A equals f of B, and so here f of B equals f of A, dot, 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 Rolle's theorem applies. Rolle's theorem applies. Okay, and also we know that have to note this function, just based on the nature of polynomial function, is going to be continuous and differentiable over this interval. So let's go ahead and work this out. We're going to take the derivative f prime of x is going to be equal to 4 x cubed minus 4x. And so at where the f prime of x is 0, we're going to have 4x cubed minus 4x. And solving for x, we're going to take a greatest common factor out of this, and that would be 4x And 4x times quantity x squared minus 1. So 0, that, and we can rewrite all this as 4x, and using difference of squares, we're going to have this x squared minus 1 can become quantity x plus 1 times quantity x minus 1. And so we'll have x be equal to 0, x can be equal to negative 1, x equals 1. And so these are three values of where, so c can equal x equals 0, x equals negative 1, or x equals 1. That's where Rolle's theorem will apply. And so let's go on to the next situation. Three values, possible values for c here. Okay, next problem, our last problem. Let f be a function that is differentiable on the interval, the open interval 1 to 10, if f of 2 equals negative 5, and f of 5 equals 5, and f of 9 equals negative 5. Which of the following must be true? So let's go ahead and kind of draw a little sketch to help us view the situation. So we have from 1 to 10, and f of 2, so here at 2, our output value is 5. So this is f of 2 is 5. Excuse me, that's going to be negative 5. I got it wrong here. Okay, we'll say negative 5. Okay, that's not going to be it. Okay, f of 2 is negative 5. And f of 5, and so here's 5. F of 5 is positive 5. And f of 9 is negative 5. And what we have here is a Rolle's theorem situation, because we can say that this value here is going to be f of a at negative 5 here, and f of b. And so we have a average slope of 0 between these two. So the first problem is f has at least two zeros. Well, if we say that the function is differentiable, we also know the function has to be continuous. And so we have something that looks like this. The function will go up from here, and it's going to cross the x-axis at some point, touch this, could go up some more, we don't know, but eventually we'll be coming back here at 9 to equal this. Now, this looks like it fails the vertical line test here, but here's our function. It'll just qualitatively look something like this. And so according to the IVT, there has to be at least two zeros. One between 1 and, between 2 and 5, and also between 5 and 9. 2, the graph of f has at least one horizontal tangent. Well, according to the Rolle's theorem, we're going to have a value c, and here, according to the drawing, it's up here. So we have c up here, and our horizontal tangent right like this, and then for some c between 2 and 5, f of c equals 3. Well, let's see, we have, between 2 and 5, here's between 2 and 5, and that's another local IVT problem, because between 2 we have a value of negative 5, and between, we would write that out as 3 is going to be greater than f of 2, but less than f of 5, which according to the IVT, this applies. So this would be a multiple choice type problem, and we would be able to pick all three, 1, 2, and 3, as part of this. And so anyway, this has been a few problems showing mean value theorem application and Rolle's theorem. And I hope this has been helpful to you, and thanks for viewing.